Okay, welcome back everyone to Grockit's OGTV. This is the GMAT edition. We're going through the 12th edition to the guide to the test, like it says here in the lower, there we go. Like it says in the lower left-hand corner of the screen. My name's Jim Jacobson, like it says in the upper right-hand corner of the screen. And we're going through right now we're going through the section of data sufficiency questions. Well, I think we are approaching, we're over halfway done. There are, I guess we are not quite halfway done actually. There are 174 questions. So we will approach halfway done today, but in the next couple days we'll hit the halfway mark. So where we left off last time was on page 278. We got to the end of page 277. Now we're on page 278 with question number 59. And as always, I write down the side here on data sufficiency questions what each of those answer choices stands for as a reminder, because it's my preference to just have that there. It ensures I don't inadvertently click the wrong thing, and also helps ensure it helps me not have to read the answer choices on the real GMAT. So 1, 2, 10 doing this, I can cross off these without reading the answer choices just to make extra sure I'm getting the right one. Your mileage may vary. If you have the answer so strongly encoded in your brain, then by all means just go ahead, write down A, B, C, D, E when you're eliminating wrong answer choices. But since I'm the one who does the broadcast, I get to decide what I write down the side, and I'm going to do the thing that I like to do. Anyway, and I just deleted my thing. I'm sorry about that. So yeah, like I said, page 278, number 59. So if a total of 84 students are enrolled in 2 sections of a calculus course, how many of the 84 students are female? So we know that the total is out of 84, and we want the females in the 2 sections. So in order to answer this question, we need to know the actual number of females so that we can get the rest of this ratio, the rest of this fraction. We don't get any other additional information about them though, so we need to go to the statements. Statement 1 says 2/3 of section 1, 2/3 of the students in section 1 are female. So 2/3 of section 1 are female. There are 2 sections, of course, so just knowing what section 1 has, there's no way that can be sufficient on its own. So we can cross off answer choices A and D. Those require statement 1 to be sufficient. Let's take a look at statement number 2. 1/2 of the students in section 2 are male. Actually, and since 1/2 are male, that's the same thing as saying 1/2 are female. So now we have that one in terms of female, but this one says nothing about section 1, so this can't be sufficient on its own. We can cross off B. Now the only 2 answer choices, C and E, hinge on consulting the 2 statements together in conjunction and determining whether they contribute to sufficiency. So, statement 1 tells us that 2/3 of section 1 are female and 1/2 of section 2 is female. However, without getting actual numbers, remember we need an actual number up here in order to figure out what this ratio represents. And because we aren't given a total, we're given a total, but not a total of each section, or even some clue about what actual number some fraction of one of the sections might represent. Even in conjunction, these are very different. If section 1 is much larger than section 2, because there's no indication that these 2 sections are the same size. If section 1 is much larger, that creates a very different fraction than if section 2 is the much larger one, because if 2/3 are female, then you have a much larger total number. So even in conjunction, these 2 statements are insufficient. We cannot use the 2 of them together, and so answer choice E, neither statement on its own nor in conjunction, is sufficient. Okay, 278, question 60. What is the value of n in the equation negative 25 plus 19 plus n equals s? So negative 25 plus 19 plus n equals s. And we can simplify this a little bit. That, of course, gives us n minus 6 equals s. So we need to know the value of n here. And to solve for n, we could either be given outright the value of n in one of the statements, or if we were given the value of s, we would also have sufficiency. So we have one equation and two variables, so we just need additional information to solve it. Statement 1 tells us that s equals 2. Well, that flat out gives us a value for s. We could plug this in here, so n minus 6 equals 2. So n equals 8. And of course, we didn't have to do that math if we recognized immediately that this gave us another unique equation for our two variables, one equation problem. And so this on its own, without even doing the rest of this math, was sufficient. So statement 1 is definitely sufficient. We can cross off B, C, and E. Let's take a look at statement 2. Statement 2 gives us n over s equals 4, which again is a separate, distinct equation, but it may not be as immediately clear to you how we could use this. We multiply both sides times s, and we end up with n equals 4s, which might make it a little bit more apparent, because then we can just plug this value here into our original equation. So then it's 4s in place of n minus 6 equals s. So then we subtract an s from both sides and add a 6 to both sides. We get 3s equals 6, and then s equals 2, which is in keeping with our original equation. Remember, when the two statements are sufficient, they will get you the end result. So n minus 6 does equal s still. That's a way of kind of double checking. If you're headed towards answer choice D, each statement is sufficient. They should both point you in the same direction. If they do, you're all right. If not, you've done something wrong. Anyway, D, either one is correct and sufficient on its own. Still page 278. Question number 61. At a certain picnic, each of the guests was served either a single scoop or a double scoop of ice cream. How many of the guests were served a double scoop of ice cream? So I guess it's worth pointing out, perhaps, in case this isn't obvious, maybe this is obvious, s equals 1 scoop. A single scoop is 1 scoop, a double scoop is 2 scoops. That's more background information than necessarily information we're given from the passage. Or, I mean, I guess we're given it, but, Anyway, moving on. It becomes important later. Statement number 1. At the picnic, 60% of the guests were served a double scoop of ice cream. So 60% were double scoops. So this tells us that 40% were single scoops. And that the ratio of single to double scoops was 40 to 60, or, so that's single to double, and this is people. We could just simplify this fraction to 4 to 6 or 2 to 3. Now we've been given the ratio of people, but we need to know how many guests were actually served a double scoop of ice cream. So even though we were able to figure out this useful information, it's not going to be sufficient. So it's not A and it's not D. Let's take a look at statement 2. Statement 2 tells us that 120 scoops of ice cream were served to all the guests at the picnic. 120 scoops. So, I mean, this would tell us, for example, that the number of people who got single scoops plus 2 times the number of people who got double scoops equals the 120 scoops of ice cream that were given out. But there's multiple values for the single and the double scoops that allow us to, that come up with the same total of 120. So because we can't narrow it down to a single value for the single or the double, these two are there, or this information also is insufficient. We can cross off answer choice B. Now we need to look at the two in conjunction, and things get more interesting. So we know then that we know that there is a the ratio is 2 to 3 for people who are sorry, I'm spacing out for a second here. Oh, right, yeah. The ratio is 2 to 3 for the people at this picnic. So if we translate this into scoops, every person who was getting a single scoop also then got 2. So actually, I'll rewrite it down here. 2 to 3 is our ratio of people. If we figure out how many scoops this represents, then this is the single, this is the double. Every two people who were getting single scoops got 2 scoops. And for every 2 of those people, there were 3 people getting double scoops, so that's actually 6 scoops of ice cream. So for every 5 people, 8 scoops of ice cream were used, which means that this 120 scoops here should be divisible by the total of this ratio. So 6 plus 2 is 8. So 120 divided by 8. So every group of 8 scoops represents 5 people going through. Gives us 15. And so then we multiply 15 times that ratio of 2 to 3 people, and we get 30 to 45. And these are the actual numbers. There were 30 single scoop people and 45 double scoop people. We can double check our math. 30 single scoop people getting single scoops gives us 30 single scoops. 45 double scoop people getting 2 scoops each is 90 scoops. 30 plus 90 is 120, which is what statement 2 gives us. However, if we were comfortable with our math, we could have stopped a little bit before that. The 2 statements in conjunction are sufficient. So we can circle answer choice C. Or select it and confirm it, and move on to the next question, which is number 62. For a certain convention, a hotel charges a daily room rate of $120 for one person and X dollars for each additional person. What is the charge for each additional person? Okay, so we are given kind of an initial, so the cost, is going to be 120 plus X times the number of people equals the cost. It's not really an equation we can do much with because we're given, that's 3 variables basically, X, the number of people, and the cost, but it's the framework that we can fill in. Oh, sorry, actually it should be people minus 1 because the first person is paying the $120 rate. So actually, sorry, 120 plus X times number of people minus 1 equals the cost. Let's take a look at those statements. Statement 1, the daily cost per person for 4 people sharing the cost of a room equally is $45. Cost for 4 people is, using our formula, 120 Number of people minus 1 would be 3 times that rate of extra persons divided by 4 for 4 people, that equals 45. This is a straightforward single variable algebraic equation. So, we could, it would be 120 plus 3x equals 180, and then, 3x equals 60 and x equals 20. But really, we don't really have to do this if we can look at this here and say, well, I know I could solve for x, and that's all I need to know, so statement 1 is sufficient. We would cross off B, C, and E because those require statement 1 to be insufficient. See what statement 2 gives us. The daily cost per person for 2 people sharing the cost of a room equally is $25 more than the corresponding cost for 4 people. So this tells us, so the room rate for 2 people is $120 for the first person, plus just that straight up X dollars for the second person, divided by 2, because that's that average rate, and that is $25 more than the cost for 4 people, which is that same fraction that we already used, 120 plus 3x divided by 4, and it's $25 more than that. So even though this ends up looking kind of ugly, there is still only one variable. We would multiply every part of this equation by 4, and then subtract some x's and things like that, and it would come out to be the same answer, that x equals 20. So statement 2 is also sufficient. We can cross off A and confidently select D. Either statement on its own is sufficient. When you get to the point where there's just one variable and a bunch of other numbers, you can definitely go from there. Okay. 278, number 63. Stores L and M each sell a certain product at a different regular price. If both stores discount their regular price of the product, is the discount price at store M less than the discount price at store L? Nothing we get from the initial statement. We just want to know, is L's price, or is M's discount, price less than L's discount price? In order to solve this, we need to know their relative discount prices. So let's see what the statements give us. At store L, the discount price is 10% less than the regular price. At store M, the discount price is 15% less than the regular price. So L discount equals 10%. The M discount equals 15%. So that is good to know, but without knowing the original prices, we don't know whether the discounted price, how these two prices stand in relationship to each other. So even though M's discount is higher, it may be that they have a much higher initial price, and so a 15% discount may still have a higher discounted price than L's discounted price, even though it has a smaller discount. So statement 1 is insufficient because we need to know what percent, what the original prices are that these discounts are applied to. So it's not going to be A, and it's not going to be D. Statement 2, at store L, the discount price is $5 less than the regular store price. At store M, the discount price is $6 less than the regular price. So here we have the L discount is $5. And here we have the M discount is $6. But again, without knowing the original price, without knowing what we're subtracting $5 or $6 from, we have no way of knowing whose final price is lower. So, you know, if M costs $100 normally and L costs $50 normally, taking $6 off of 100, you still have a much higher final price than taking $5 off of 50. So this is insufficient on its own, and we can get rid of choice B. All that's left is the two in conjunction. But here we actually have some useful information. We can say that because the percents in statement 1, we find out what that discount represents in statement 2. So we know, for example, that 10% of L's full price equals $5, and we know that 15% of M's full price equals $6. And then where that gets us, you know, so that's 0.10 times L equals 5, and 0.15 times M equals 6. We divide both sides by 0.1 and 0.15 respectively. So we end up with L equals 50 and M equals 40. And then we can actually subtract the dollar amounts. And again, we wouldn't actually have to go this far on the GMAT, because once we get to this point, we know we can figure out what the full prices are and which one's going to have the higher discounted price or the lower discounted price. But so L's discounted price will be 50 minus its $5 discount. M will be 40 minus its $6 discount, which equals 32. So in this case, M's discount price is lower than L's discount price. We didn't actually have to get all the way there, we just had to know that we could. The two statements together are sufficient. We can cross off the neither option and circle choice C. Okay, page 278, number 64. If D denotes a decimal, is D greater than or equal to 0.5? Is D greater than or equal to, oh no, stupid computer. Is D greater than or equal to 0.5? So nothing we can do until we get to the statements, because we don't know anything else about decimal D. When D is rounded to the nearest tenth, the result is 0.5. D rounded equals 0.5. Now remember, of course, with rounding, you can either get to 0.5 by having the next digit less than 5, or have the first digit be 0.4 and then have the second digit be 5 or greater. So for example, the decimal 0.46 and the decimal 0.52, both of these when rounded get us to 0.5 flat. And since the question is the decimal greater than or equal to 0.5, here it's greater, here it's less. This makes the answer to D, the information that we get from statement 1, it makes it sometimes yes and sometimes no, which is not sufficient to answer our question for a yes-no question. So we cross off A and we cross off D. Statement number 2 tells us that when D is rounded to the nearest integer, the result is 1. D rounded to integer, which means that the first place after the decimal point, so this place here, this place, in order to round this digit to 1, this digit here needs to be greater than or equal to 5, because that's how rounding works. So it could be a 5, or a 6, or a 7, or an 8, or a 9, and it doesn't matter which, because each of these answer choices is greater than or equal to 0.5. So any digit from 0.50 upward to, I guess it's 0.50 to 0.99, any of those would round up to 1.0. And since the question is asking is d greater than or equal to 0.5, every single one of these answers that rounds up to 1.0 is greater than or equal to 0.5. So answer choice B on its own is sufficient, eliminating C and E. Second column on page 278, number 65. How many integers are there between but not including integers r and s? So, if we have a number line here, we have r here and s here. We want to know how many integers are between them but not including them. So it would be that kind of situation where we need everything up to and including those integers, but not including those integers. But that doesn't tell us anything. So let's take a look at the statements. S minus r equals 10. So what this tells us is that the difference between r and s is 10. Keep in mind, of course, and this doesn't really matter for the purposes of this question because we just need to know that we could solve for the number of integers. So it's already sufficient and we can cross off B, C, and E. The number of integers between the two is actually 9. Do we actually get well, the number equals 9. So the difference between two numbers is 10. So the difference between 11 and 1 equals 10, but there are actually only 9 digits between the two. Yeah. So because 2, 3, 4, 5, 6, 7, 8, 9, 10 is not a full 1 to 10, it's only 2 to 10, which is 9 digits. Good story. Anyway, just a thing to remember about counting things. The difference between two numbers is not the number of numbers between two numbers. Statement number 2 tells us there are 9 integers between but not including r plus 1 and s plus 1. So, in terms of our number line here, we have r plus 1, s, and s plus 1. And this one tells us a similar sort of thing, that there are 9 digits between those numbers. And of course, if there are 9 digits between, between r plus 1 and s plus 1, there are also 9 digits between s and r. It's just shifted this same distance on the number line to the right 1. So it's exactly the same line or figure, however you want to think about it. So this statement also is sufficient. So statement 2 sufficient also, either one sufficient on its own, that's answer choice D. (278), number 66. If n and t are positive integers, is n a factor of t? So another way to think about that, if n is a factor of t, t divided by n, that will come out to be an integer. Okay, that means that t is evenly divisible by n, because any number is evenly divisible by its factors. Whatever factors those are, you can evenly divide that larger number by the smaller number that are its factors. So t divided by n is an integer. Or is t divided by n an integer? So this is a yes-no question. We need the answer to be always yes or always no. So our first statement gives us n equals 3 to the n minus 2. So this doesn't tell us anything at all about t. No, I put the parentheses around t so it didn't just look like I wrote not there. Anyway, there's no t for statement 1, so we really wouldn't be able to determine whether t divided by n were an integer. So statement 1, not sufficient on its own. That eliminates A and D. Statement number 2, we have t equals 3 to the n. And so there's a couple different values that we could choose. If t equals 3 to the n, sorry, that's a question mark for the original question. So if n equals 2, t equals 9, 9 divided by 2 is not an integer. If n equals 3, then we're going to get, 3 to the third power. T equals 27. 27 divided by 3 is an integer. So this is a sometimes yes, sometimes no situation. So statement 2 is definitely not sufficient on its own. And we can cross off B. All that's left is the 2 in conjunction. So we have n equals 3 to the n minus 2 and t equals 3 to the n. The original question, though, is asking what is t divided by n? And so that's kind of our way into this one. T divided by n, we have 3 to the n divided by 3 to the n minus 2. And the reason this is convenient is that we have two exponents of the same base. So that makes our life a lot easier. Remember, when you have two exponents of the same base and you divide one exponent by another, like x to the a over x to the b, that equals x to the a minus b. So it works the same way here. This is 3 to the n minus 2. So n minus n is 0. Minus 2 is positive 2, so that equals 3 squared, which equals 9. So, and that's t divided by n. T divided by n did give us an integer, so n is a factor of t. The two statements in conjunction are sufficient, and we can select answer choice C. Okay, 278, number 67. In a survey of 200 college graduates, 30% said they had received student loans during their college careers, and 40% said they had received scholarships. What percent of those surveyed said they had received neither student loans nor scholarships during their college careers? So this is one of those overlapping sets problems. You remember this, the credit card logo, where we have A, B, both, and over here, neither. And the formula is A plus B minus both plus neither equals your total. And we have a bunch of these numbers. So now remember, the total here is 200. And A is 30% of the 200 students. So 30% of 200 is 60. And then we have 40% of 200, and that's 80, minus those who are doing both, plus those doing neither, gives us 200. So, and the question is actually asking us how many are neither. So if we can figure out both from the statements, what the number that both received loans and scholarships, we can figure out neither, and we win, or at least have sufficiency. Statement number 1, 25% of those surveyed said that they had received scholarships but no loans. So 25% of 200, which is to say 50, oh, and I should probably make these clear here. So the loans are the 60 and the scholarships are the 80 there. It's a helpful reminder. Okay, so 25% surveyed said that they had received scholarships but no loans. So 25% of 200, that's 50 people got scholarships but no loans. So the total number that got scholarships, which overlaps with the number that also got loans, is 80. And what this means is that the number just purely within the circle here without the both, so it's 80 is the whole circle, the part that is in the scholarships portion without the number that's both is 50, so 80 minus 50 tells us that 30 is our number for both. And with both, then we can solve the rest of the way and figure out how many got neither. Statement 1 is sufficient. Cross off B, C, and E. Statement 2. 50% of those surveyed who said that they had received loans also said that they had received scholarships. So 50% of those who said that they had loans, so 50% of 60, which is the loan number, got both, which is another way of getting at our both number. 50% of 60 is 30. So 30 is, again, our both number for our big equation here. And again, with that solved, we only have one variable left, and that's neither, which is what we were solving for. So statement 2 is also sufficient, meaning answer choice D is the correct one. (278), number 68. Three machines, K, M, and P, working simultaneously and independently at their respective constant rates, can complete a certain task in 24 minutes. How long does it take machine K, working alone at its constant rate, to complete the task? So this is one of those fun ones that asks you to kind of derive the work formula over again. And you can either remember the work. In this particular case, it's more useful to know how to derive the work formula than it is to actually use it, because you'd have to re-come up with it, and we only are given ever one. We're trying to solve for one of the three machines. So that basically we know that the three machines working independently can complete the task in 1/24th, or in 24 minutes. So in 1 minute, 1 fraction of K plus 1 fraction of M plus 1 fraction of P. This is the amount that they do in 1 minute. They do 1/24th of it in that time. But of course, with 3 variables and 1 equation, we definitely don't have enough to go on. So we have to get to the statements. Statement 1, machines M and P working simultaneously and independently at their respective constant rates can complete the task in 36 minutes. So this tells us machines M and P, 1 over M plus 1 over P equals 1 over 36, because they can do 1/36, 1 minute's worth. That's this. And we have this same fraction up above. So this tells us that 1 over K plus 1/36, which is 1 over M plus 1 over P equals 1/24th. So 1 over K would end up being whatever 1/24th minus 1/36 is. It looks like it would be unpleasant to figure out what 1/24th minus 1/36 is, because we would need to find a common denominator of those two numbers. Not that it would be impossible, but figuring out what that would be, I don't know. That doesn't sound that fun to me. All we need to know is that we could solve for K in this equation, and that's enough for sufficiency for statement number 1. So it's not B, nor C, nor E. Now the question is whether the two statements are independently sufficient. Statement 2 tells us machines K and P working simultaneously and independently at their respective constant rates can complete the task in 48 minutes. So this tells us that 1 over K plus 1 over P equals 1 over 48. Which then, it would allow us to solve for 1 over M. We get 1 over M plus 1 over 48 equals 1 over 24. So 1 over M equals 1/24th minus 1/48th, which I guess will actually be 1/48th, because 1/24th is 2/48ths. But knowing that 1 over M is 1/48th still doesn't allow us to plug this back in to our fraction above, because then we would still have 1 over K plus 1/48th plus 1 over P equals 1/24. We're not allowed to use what we have in statement 1, and so because we still have two variables in one equation, it's not sufficient. You need two equations for two variables. So statement 2 is insufficient because it doesn't allow us to isolate machine K, which is what we needed to do. So it's not D, it is in fact answer choice A. Last one on this page, 278, number 69. Of the four numbers represented on the number line above, is R closest to 0? Let's get that number line up here. Really kind of more of a letter line. Q, R, S, T. Anyway, statement 1. Q equals the opposite of S. So what this means is if Q equals the opposite of S, we know that they have the same absolute value. Okay? They have the same distance from 0 on the number line, and in fact they are mirrored around 0 on the number line. So we don't know these relative distances, Q, R, and S. R could actually be much closer to Q, it could be much closer to S. We do know that exactly between the two is going to be 0. Let's put that in another color. So 0, and it doesn't even matter where 0 is. I mean, it needs to be evenly distributed between Q and S. That's a 0. So 0 is here. Now it could be on this side of R, it could be on this side of R. We don't actually know where it is relative to R, but we do know that R is going to be the one closest to it, because Q and S are going to be the same distance from 0, and R is between Q and S. Therefore, R is closest to 0 of the four numbers on or of the four letters on our number line. So this just tells us that Q and S, or Q plus S equals 0. They're opposites of each other. They are mirrored around 0, and R is between them. So it's sufficient, it's not B, and it's not C or E. Statement 2, the opposite of T is less than Q. Well, what this tells us is that T is closer to 0 than, or sorry, Q is closer to 0 than, no wait, yes, Q is closer to 0 than T is, because if the opposite of T is less than Q, it puts it somewhere over there. Actually, it doesn't even tell us that their relationship necessarily, and it certainly doesn't tell us whether R is closest to 0. If T is, we can pick a whole bunch of different numbers here, which place Q, T, and 0 in all different places. So there's basically not enough information here to determine R's position, because S and the relationship to 0 isn't set when we have an inequality rather than an equation. So, if Q is 1, then negative T is going to it has to be less than that, but that's not saying much, which means that negative T could be negative 2 or negative 133. And it skews the relationships between everything. So statement 2, not sufficient. It's not D. It's definitely answer choice A. Okay, 3 more it looks like. On to page 279, number 70. So Mary persuaded N friends to donate $500 each to her election campaign, and then each of these N friends persuaded N more people to donate $500 each to Mary's campaign. If no one donated more than once, and if there were no other donations, what was the value of N? So in round 1 of her campaign fundraising, she raised $500 times this number of people. Round 1. in round 2, she raised each of these n people. So it was 500 times the number of people times the number of people, because every one of those original n people got 500. They got n more people times $500. The two rounds together are then 500n plus 500n squared, which we could also rewrite as 500 times n squared plus n, or 500 n times n plus 1. All those are the same thing. Okay, and we don't actually know which is going to end up being useful. And in general, you don't necessarily want to go too crazy with all the different formats, but it was pretty easy to see different ways of factoring it. So, statement 1, the first n people donated 1/16 of the total amount donated. So the first n people, we know they donated 500n. This is statement 1. Statement 1, the 500n that they first got is equal to 1/16 of the second amount. And since we have a 500n on the left, we're going to use this guy here on the right. 1/16 of the total amount. And from there we can see that we would isolate those. We get n plus 1 equals 16 and n equals 15. So that's sufficient. It's not B, it's not C, and it's not E. Statement 2, the total amount donated was 120,000. So again, we still know here that this is our total amount here. 500 times, and it doesn't matter which one we use, 500 times n squared plus n equaled 120,000, and divide both sides by 500. We get n squared plus n equals 240. N squared plus n minus 240 equals 0. And it turns out it's n minus 15 times n plus 16 equals 0. And since we can't have negative numbers of people going out and doing anything, it's naughty, n again equals 15. So it's sufficient. It's not A, it is D. It is enough to know, actually, in terms of this, you could have stopped here with that initial equation because we had one equation and one variable. You could have also stopped here. And once you realize that you have one equation and one variable. I suppose you would have had to worry about two possible values for n because it's a quadratic equation. So if nothing else, once you got to this point, recognizing that one would be a positive number and one would be a negative number, you don't actually have to solve the rest of the way because only one of the possible values for n would be valid with a number of people. So answer choice D, both statements are sufficient in their own right. And 279, number 71. Carlotta can drive from her home to her office by one of two possible routes. If she must also return by one of these routes, what is the distance of the shorter route? So S will be short, L will be long. Statement 1, when she drives from her home to her office by the shorter route and returns by the longer route, she drives a total of 42 kilometers. So this tells us that the short route plus the long route equals 42. Whenever you're given a simple equation like this, two variables, one equation, you literally have no way of solving S plus L equals 42 because there are so many different numbers that, I mean, it's not infinite if we're dealing with distances, which have to be positive, but there's a lot of different combinations of numbers, and it's not going to be sufficient because we need a single value. Statement 1 is insufficient. It's not A, and it's not D. Statement 2, when she drives both ways from her home to her office and back by the longer route, she drives a total of 46 kilometers. So long way there plus the long way back equals 46. Now this tells us that L equals 23, but the question was actually asking us what S is. We want the shorter route. So statement 2 on its own gives us L, but not S. It too is insufficient. So we can cross off statement 2 on its own. Looking at the two together though, we have two equations and we have a really easy substitution. We can just put L in for that value and we can figure out what S is. The two statements together are definitely sufficient. Answer choice C. Okay, last one. Last one I'm going to do today anyway. Since we published the schedule in advance, we try to stick pretty closely to the number of questions, and I've found that basically I get through about 14 questions every session, give or take. And so I just aim for 14. And then hope you tune in next time for the next question. Okay, is x greater than y? A good question. And with no other information, we have to hit the statements. Statement 1, x equals y plus 2. So what this one tells us is that we have to add 2 to y for it to equal x, which means that by definition, x is 2 more than y, therefore x is greater than y. Exclamation point. So this one just flat out is sufficient for us to answer the question. This one tells us that x is in fact 2 more than y. So we can cross off B, C, and E just from that first statement. Second one, we have x over 2 equals y minus 1. That's an equals, not an inequality. So we multiply both sides times 2, we get x equals 2y minus 2. So it's harder to tell the relationship between these two numbers. So let's do a little graph here. If y equals this, then x equals this. So if we say that y is 0, 2y minus 2 is going to be negative 2. Here we have y is greater than x. And having done statement 1, we already know we're in trouble, but you still want to check because it's possible we did something wrong with statement 1. If we go with an increasingly negative number, negative 1 for y, then x is going to equal negative 4. Y is still greater than x. If we have y is 2, then 2y is 4 minus 2 is 2, so they're 2 and 2, y equals x. And let's just pick on 3. 2y minus 2 is going to be 4. So then x is greater than y when y equals 3. So this is clearly a sometimes yes and sometimes no question. Is x greater than y? Well, it depends on what the value of y is with statement 2. Statement 2 is definitely insufficient, leaving answer choice A. Statement 1 on its own is the only sufficient answer. So I think that's a good place to stop. Next time we will do another 14 questions, starting with question number 73 on page 279. And so I hope to have you back next time. Thanks for tuning in. You've been watching Grockit's OGTV, the GMAT edition. Like it says here, GMAT, oh, lost my pen. GMAT 12th edition to the guide. That's the one with the kind of purpley cover. And my name's Jim Jacobson. You've been listening to me go through the problems cover to cover, question by question. See you next time.